This week, we will be learning how to evaluate statistical claims. This will be the last in our series on data analysis and problem solving. And we won't need to do any calculations, we will just need to hone our critical thinking skills. We will essentially be answering this question. Given an experiment, how do we make claims based on the results? This question relies on two different ideas. The first is random selection, which determines whether or not we can generalize our claims to an entire population. The second is random assignment, which determines whether or not we can make conclusions about cause and effect within our experiment. Note that both of these rely on two different ideas of randomness, which is key to valid statistical claims. First, we'll look at random selection, which allows us to generalize claims to an entire population. Recall from last week that the population is the group that we're making claims about. The sample, which is taken from the population, is the group that we're actually directly testing. So the essence of random selection is that our sample needs to be randomly selected from within our population. If our sample is not truly randomly selected from our population, then we cannot generalize the claims from our experiment to the entire population, only perhaps a smaller subset within that population. Suppose we want to show that Europeans travel more than people in most other countries. We survey 100 European flight attendants and find that they travel far more frequently than the world average. Could we appropriately claim that Europeans travel more than most of the world? Of course not. It's the job of flight attendants to travel. So we haven't surveyed the habits of Europeans, we've surveyed the habits of European flight attendants, a very different group within that full population. By sampling only from European flight attendants, we have a clear bias in our data. So instead, we would only be able to make claims about European flight attendants, not all Europeans. When you're evaluating statistical claims in the future, make sure that the sample is truly randomly selected from the population. What is the lesson here? Our population is all Europeans, but our sample is just European flight attendants. So the lesson is that our sample here is not randomly selected from the population, so it is not an accurate or appropriate sample. Next, the notion of random assignment, which we will look at with a different example. You've conducted an experiment on 15 students in an SAT class, chosen at random from 100 students at a test prep center. You offer every student extra online review videos. At the end of the course, you observe that students who viewed the online review videos did better on the test than those who did not. Based on these results, what is the most appropriate conclusion? First, we apply our understanding of random selection to eliminate some of our answer choices. In this question, our sample is 15 students in an SAT class chosen at random from the 100 students at the test prep center. Looking to A, this asserts claims about improved learning in any class, but that is an overgeneralization because we're only sampling from an SAT class. So we eliminate A. Likewise, B asserts learning improvements for all students, but our sample is only from students at this test prep center. So again, that is an overgeneralization. So we likewise eliminate B. Now we are just left with answers C and D, which effectively say opposite things about cause and effect. So we have to ask ourselves, can we claim that watching the online review videos causes improvements in test performance? It may appear yes. However, note very importantly that all of these students who watched the online review videos chose to watch those videos, while those who did not chose to not watch them. Picture a classroom with 10 lazy students and 10 ambitious students. If you let all 20 students choose whether or not to watch the additional review videos, of course the 10 ambitious students will watch them, while the lazy students will not. But you also expect that the ambitious students are going to try hard, pay attention, and do their homework. Therefore, when the 10 ambitious students score higher on the SAT, their improvement may have been caused by one of those other reasons, not necessarily by watching the online review videos. This introduces the notion of random assignment, which says that only if subjects are randomly assigned to treatments can claims be made about cause and effect. Now in this case, the subjects are the students and the treatments are watching the online review videos. Because the students chose themselves whether or not to watch the online review videos, these subjects were not randomly assigned to their treatments. Therefore, we were not randomly assigning them and cannot make conclusions about cause and effect. As a counterexample, if we were to do the test again, instead forcing one random half of the class to watch the review videos and not allowing the other half to watch the review videos, then we can make claims about cause and effect, because the students viewing the videos will be some lazy, some ambitious. Only with this alternative experiment could we make conclusions about cause and effect. Because we did not satisfy random assignment in our actual experiment, we cannot make conclusions about cause and effect. Therefore, looking at our answer choices, we see that in the end, D is the only correct answer. You'll often hear this summarized as correlation is not causation. In this case, there is correlation between watching the online review videos and improved test score performance. However, there is not necessarily causation, at least we have not proven so in our experiment. Today's concepts can be very neatly summarized in the table seen here. When you see a question asking about statistical claims, be sure to first question whether their sample was randomly selected from the population, allowing for conclusions to be made about the entire population. Then, question if the treatment was randomly assigned to the subjects, allowing for conclusions regarding cause and effect. And that finally wraps up everything you'll be expected to know for the SAT on data analysis and problem solving. So like I said before, not only is this really useful for the test, but these are ideas and skills that are so applicable even beyond this one test you'll have to take. Hope you liked the video. If you want to hear more and see what else we're up to, hit like and subscribe, and see a new video coming out from Point Avenue every week. If you want to talk to us, hear more about what we're doing, or have any questions, email us at contact@pointavenue.com. Bye!